Good evening. Tonight we're looking at laws of logarithms. So first of all, when dealing with logarithms, we're going to let b be the base of a logarithmic function, where b is greater than 0 and b cannot equal 1. We're going to let m and n be positive numbers or variables. So right here we have log base b of mn. So since we're multiplying these arguments together, we can expand and write this as addition. So we can write log base b of m plus log base b of n. That's one of the laws of logarithms. You can go the other direction as well. If you're adding logarithms, you can rewrite it multiplying the arguments together. So here we have division. So remember, when dividing exponents, you subtract them. So the log base b of m subtract log base b of n. Does this sound familiar? Remember, when multiplying exponents, you add them. Okay? When dividing, you subtract. Now here we have, this is the one law that we've already been using, where we have log base b of m to the k power, and remember that k power comes down front, just like that. So when you have an exponent raised to an exponent, you multiply. So here are your laws of logarithms. Now we're going to use those laws down here to expand the following expressions. So to expand this, first of all, we look and say, okay, so we're multiplying these arguments together. So we're going to expand it out. So log base 2, when multiplying, you add, correct? So log base 2 of 5 plus log base 2 of a plus log base 2 of b. And we've expanded it out. And remember, if it's expanded, you can go the other direction as well. When adding, you multiply. Okay, so here we have a division. So when dividing, what do? We subtract. Top to bottom, log base 5 of 8 minus log base 5 of x. Pretty simple. Okay, so now we have a combination here. We have some multiplication going on, and we also have some exponents going on. So the first thing we're going to take care of here is the multiplication. So we're going to have log base 2 of 6 plus log base 2 of x squared plus log base 2 of y cubed. So we just applied the first law to expand it out. Now we have some exponents here. So we're going to apply the third law here, where we're going to bring the exponent down front. So there's no exponent to bring down front, it's just 1. So that's going to stay the same. Here we have a 2, so we're going to take that 2 and we're going to bring it down front. So plus 2 log base 2 of x. Bring the 3 down front, 3 log base 2 of y. And there you go, completely expanded out. One thing to keep in mind too is that when you're in expanded form and you want to go back to the condensed form, the bases have to be the same in order to do that. Okay, number 4, again we have a combination of things. So what you want to do here is we want to start by working in the numerator, okay, first. So we're going to have log base 3 of 4, okay, then it's being multiplied, so add log base 3 of a squared, okay, and then division, so we're going to subtract log base 3 of b, This is multiplication plus log base 3 of c squared. So again, multiply is add, okay? Divide, subtract. Multiply is add. Last thing we take care of is our exponent. So we're going to use rule 3 up here. So this first one is fine and dandy. The second one has an exponent, so it's going to come down front. This one's fine. And bringing the exponent down on the last one. And there's your completely expanded form. All right, turn the page. Let's keep moving. All right, number 5. So, does anybody remember what the square root represents as a rational exponent? Yes, that's right. It represents the 1/2 power. So what we have here is, and by the way, notice the base is missing. Well, when there is no base written, it's base 10. It's base 10. We don't have to write base 10. Base 10. If you do not see any number here, it's base 10. It says it right here. It's called a common logarithm. Okay? All right. So I'm going to go ahead and rewrite this. Log, I'm going to put this in parentheses. And instead of a square root symbol, I'm going to use a 1/2. Okay? Now, before I expand this out, I'm going to go ahead and distribute the 1/2 onto each term. So we're going to have log, and on top we're going to have 5 times 1/2, or 5/2, over b to the 1/2 power. Alright, I think I'm ready to start expanding. So we're going to have log of a to the 5/2. Division means to subtract. Log base b of 1/2. And then finally, since we have exponents, we're going to go ahead and use the third law and bring them down front. So we're going to have 5/2 times the log of a minus 1/2 times the log of b. And there you have it. Okay, now we're going the other direction. Use the laws of logs to condense the following expressions. Now notice we didn't take care of the exponent until last. We did the adding and subtracting first. Well, when you're condensing, if there are any exponents, you want to do them first. So what you're going to need to get used to seeing is that when you see that number in the front of the log, you have to raise that up as an exponent. So you would rewrite this log base 5 of 7. Remember that 7 is the argument. Okay, plus log base 5 of x, and you have to raise that 3. We're going backwards now, so 3 comes up on the x. Okay, we're condensing. Now, condense again. So, plus means, what do we do with the arguments? Means to multiply. So log base 5, condensing these into one log. Notice the bases are the same. They have to be the same or we could not do this. And this is going to be times. Okay, opposite. All right, number 7. All right, any number to move up? No. Any number to move up? No. Bases are the same? Yes. Let's condense. So log base 2, subtract means we are dividing. Okay, first argument goes on the top, second argument goes on the bottom. All right, number 8. Bases are the same, yes. We got a number in the front, so that's going to move up on top. We got a number in the front, so that's going to move up on top as an exponent. Okay, so subtraction means to divide. All right, so we're condensing into 1. First argument goes on the top, second argument goes on the bottom. Condensing. All right, number 9. So we have bases that are the same, okay? But we're multiplying this number times both of them. Now I'm going to go ahead and work this completely out. I know that when multiplying a monomial times a binomial, I would distribute it to both. So, or we could go ahead and do what's in parentheses first and then raise the 3 up on top. So either way is fine. You know, I think what I'm going to do here is, since we are simplifying, we are condensing, I'm going to go ahead and do what's in parentheses first. So it's subtraction, so we're going to divide, e log base 2, and we're going to divide a over b. Okay, now this is going to go up on top, so we're going to have log base 2 of a over b. I'm going to go ahead and put that in parentheses because the 3 needs to go on both of them. Now I could rewrite this as a cubed over b cubed. Now you would come up with that same answer if you distributed the 3 onto both, okay? Because you would have 3 log base 2 of a minus 3 log base 2 of b. And raising the 3 up onto both of them. And subtraction would be dividing, and we would be back to this answer right here. So either route works. Okay, number 10. All right, is there a number to bring up? Well, first, are the bases the same? 3, 3, 3. Yes, important. Okay, number to bring up on top? No. Number to bring up on top? Yes. I'm going to go ahead and save myself some writing here and some time by bringing it up front just like that. Number to bring up on front? Yes. So let's move it up. Cool. Now we're going to go ahead and do the adding and subtracting. So starting off here, we got an addition, which means we're going to do what with the arguments? Multiply, right. So 4 times m cubed, okay, minus log base 3 n cubed of n cubed. Okay, subtraction means to divide, so condensing down to 1 logarithm. Each time you do an addition, you're going from 2 to 1. Do a subtraction, you're going from 2 to 1. So subtraction, first argument goes on the top, second argument goes on the bottom, and there you have it. Fun, huh? Good stuff. All right, don't have much time left, but real quick here we have something called change of base. I just want you to notice something real quick here. In order to change the base, in other words, we have a base that we do not want. Okay, we want to make the bases the same. Notice b and b. We want to make them the same. We take the log of the argument divided by the log of the base. So, the log of the argument, and I'm going to run out of time here, but that's all right. Log of the argument divided by the log of the base. Okay, now we're in base 10. I'll see you in class. Try to finish these last 3 problems.